Jai Hind. The topic which we are going to discuss today is blockchain. It is the basic introduction of the blockchain. As you can look at the figure, also blockchain is nothing. It is a chain of certain blocks, basically. So we can say that it can be defined as a chain of blocks, and these blocks, they contain certain information. We will see what kind of information is residing in the blockchain. As you people have already seen how the linked list work in your C course, and you are aware that to link two nodes in a linked list, you use the address mechanism. So you can think blockchain in the similar way. Instead of a link chain, in linked list, we are having the nodes. So here we are having the blocks. In the case of the linked list, what information is present in the node? Your data, whatever you want to keep, and then the address, which point to the next address location of the next node. Similarly, in the blockchain, we are having the data. We will see shortly what kind of data we are talking about in blockchain. And here, instead of the address as we are using in a linked list, we are using a very special value, that is a hash value, with the help of which we are linking the blocks in a blockchain. It is a constantly growing ledger. Now, this term is very important, ledger, because ultimately when we say blockchain is based on DLT, that is distributed ledger technology. Ledger, you people are aware, it is a bookkeeping kind of thing where you make a record of all the activities which is being done within that organization. For example, if I talk about the ledgers for a bank, then in that case, it corresponds to the transactions which is being done in that particular bank. And when if you have ever looked in the ledger, so all the transactions which are being maintained in the ledger, they are always maintained in a chronological order, that is at what time, what date a particular transaction has taken place. That thing is also being recorded in the ledger. Also, once the entry has been put in the ledger, then you cannot overwrite in that physical ledger. So the same thing is happening with the blockchain also. Here we are also having a ledger. This ledger is basically some sorts of blocks which have been chained together. And it is a constantly growing, that is, you can add the blocks in your blockchain that keeps a permanent record of all the transactions. Now, when we use the term transaction here, then this term transaction, it not only talk about the monetary transaction, but it also talk about any kind of transfer of assets between the two parties that have taken place in a secure, chronological and immutable way. That is, whatever you have written in the blockchain, it cannot be changed, and you have to maintain an order of a transaction. How basically the chronological order is being maintained in the blockchain? It is with the help of a special value, that is it is your time stamping. We always time stamp the transactions before adding it into the blockchain. So the technique is intended to timestamp basically digital documents so that it's not possible to backdate them or tamper them, that is to modify those documents. Another important purpose of the blockchain is to solve the double spending records problem without the need of a central server. As we are aware that the blockchain is working on the distributed environment, so there is no central server involved in a blockchain technology. Now, what is a double spending problem? Double spending problem, it says that you are spending the same currency or the same notes on different locations, or you could say in different transaction you are using the same value, then this is your double spending. The blockchain is used for secure transfer of items. Now, what kind of items? As I have already told you, that transactions, it is not only the monetary transaction, it can apply to any kind of property dealing. It can apply to any type of contracts, digital contracts, signing, etc., without requiring a third party intermediary like bank or government. Once our data is recorded inside a blockchain, it is very difficult to change it. We will see later on why it is very difficult to change the records inside the blockchain. So we can say that blockchain is a software protocol. Just like your SMTP is meant for the email, blockchain is also a kind of a database, but this database is having a very specific format. However, blockchains could not be run without the internet. So, whenever you are working on a blockchain, you are always using your internet facility. It is also called the meta technologies, as it affects other technologies also. What are the other technologies involved with the blockchain? It is database, software applications, some connected computers, that is, networking protocols, and so on. So what are the key points which we have seen so far? That blockchain, it is a ledger, it is a file which is constantly growing, it is permanent. That is, once the transaction goes inside a blockchain, that is, once it is written in a block, then it is permanently put out there. It is secure. The blockchain placed information in a secure way. It uses very advanced cryptography to make sure that the information is locked inside the blockchain. Transaction being recorded in the chronological order. So it means every transaction happens after the previous one. It is quite immutable. That is, it means as you build all the transactions onto the blockchain, this ledger can never be tampered with. In this figure, it is showing the double spending problem, which we have earlier seen this term in the earlier slides. So here we are having two persons. Sender is Bob, and receiving end we are having Lisa. Bob is purchasing some books from Lisa. So he is using some kind of currency with the Lisa to purchase that book. Now what happens if somehow that currency, the Bob which is using with the Lisa, if somehow he is able to use this currency note with other person also, then this is a double spending problem. So it is a kind of a cheating which the Bob is doing with the two persons. So Bob is tendering a $10 bill to Lisa in exchange of a book. Once the Lisa receives this physical bill, there is no way for Bob to reuse this money for some other transaction, as the physical currency is now in the Lisa possession. But now consider a situation when the money is being paid in the digital form. So in this case, what we are having? We are having a digital coin. So if we say we are having a digital coin, what it implies? It implies that digital coin is a kind of a file which is a combination of certain bits. Now we can copy a file. So if you create two copies or two digital, you could say bits combination, then you could have the two digital copy of the same coin value. So in this case, Bob is using the digital coin with the Lisa, as well as a copy of this digital coin with another person, that is Alice. So this is a double spending problem. As the format for money exchange is in the digital format, it is essentially a binary physical file which is somewhere stored on Bob's device. After Bob gives this file to Lisa, he can also give a copy of the file to Alice. But now think that they have received the money without having means of authenticating the digital coin, and therefore they are delivering their respective goods to Bob. So this is double spending, where the sender spends the same money at more than one place for obtaining the services or goods from multiple vendors. How can we avoid the double spending? The one way is the one method we can use is using the centralized authority. In this case, it is your bank generally. So whenever you are purchasing something or sending from the other person, then the central authority will first verify whether you having that much amount in your account available or not. If that much amount is available, then that amount is being transferred to the leaser directly. There is no involvement, that is there is no you could say method with the help of which you can spend the same amount with the other person, because bank is verifying all the details. So in this case, we can employ centralized authority to monitor all the transactions, but it maintains a ledger book which record all the transaction, and for maintaining certain activities which the bank is running for you, you have to pay certain commission to the bank. So now the Bob has to send his digital money to the bank, who would make an entry into its ledger debiting Bob's account. After ensuring that the Bob has sufficient balance to pay for the digital money which he wants to send, would send the money to Lisa, crediting her account in its ledger. Now it is guaranteed that the Bob cannot double spend that money. If every transaction is routed through a centralized authority, then the problem of double spending would be solved. But this also provide another benefit, that is validating the authenticity of each coin as well as authenticating the users also that it received, which has been used in a transaction. So the fake money or the duplicate money would be easily detected and prevented from the circulation. But what are the problems with the central authority? The cost of creating and maintaining the centralized authority itself. As the banks need money for their operations, they start cutting commissions on each currency transaction they do for their clients. This sometimes can become very expensive, especially when you are doing the overseas transfer. All the above issues can be solved if we use the cryptocurrency, for example, Bitcoin. Before delving deeper into the blockchain, first I will give you a brief introduction of the Bitcoin. Bitcoin is basically introduced by Satoshi Nakamoto through a research paper which is entitled as Bitcoin, a peer-to-peer electronic cash system, in the year 2008. Now if you read this paper, then you will find that it not only solves the double spending problem but also offer various other advantages. One such advantage is that it maintains the anonymity in the transaction, that is, who is the sender and who is the receiver. Both parties, they are not aware of each other's actual identity. Satoshi, who created the system and did transact few coins on this system, is totally anonymous to the entire world till now. In this world, just imagine that nowadays when we are talking about the social media and where the privacy and the security of each individual is at stake, the world is not able to know who actually Satoshi is. So in fact, we do not know where Satoshi is currently residing. It is an individual or it is a group of people. If you Google it out on Satoshi Nakamoto, what are the bitcoins he is having, net worth is around $19.4 billion, and this money still remains. So what is a Bitcoin? Earlier, the bank maintains a ledger recording each transaction. This ledger is privately held and maintained by the bank. Satoshi say, why not to keep this ledger public and maintained by a community instead of a bank? So once you make a ledger public, now several issues it come to your mind. This ledger has to be tamper proof because it is known to the public, so nobody can modify its entry. As each entry in the ledger is publicly visible, we will have to figure out how to maintain the anonymity. Obviously, you would not like everybody in the world to know that I paid you $1 million or how much amount is there in your account. Also, as there is only one single ledger, keeping track of each and every transaction in the world, the size of the ledger would be a concern. And for this, we require the good, you could say, data centers to maintain the blockchain. Providing a solution to this intricacies was not trivial, and there where blockchain came into existence. So blockchain is basically not a Bitcoin, but it is a technology behind the Bitcoin. So Bitcoin, it is a digital token. What is a token? That is, in this case, it is currency. And blockchain is the ledger to keep track of who owns the digital tokens. You can't have the Bitcoin without the blockchain, but you can have blockchain without Bitcoin. The important technology which is running behind the blockchain is the cryptography. So I will just give you a brief introduction of a cryptography, and that too, public key cryptography. So basically, what is a cryptography? Cryptography is nothing. It says that you are having some data in your hand. With the help of certain key, you are converting this data into an encoded form. That is, you are doing encryption here. And your receiver will receive this encoded data, not the actual data. Now this, when the receiver receives this data, here we are having the receiver, and here at this end we are having the sender. Now receiver, he don't want to work on the encoded data, he need to see the actual data. So what he will do? He will use the key, do the decoding, and he will get the actual data. This is cryptography basically. So here we are using the cryptography techniques to making for making our blockchain secure. Even we are using the cryptography technique to creating the chains among multiple blocks. When we talk about the cryptography, we are having two categories of cryptography. One is public and another one is your private one. In the case of the private, we are having only one key, whereas in the case of the public key cryptography, we are having two keys. In this case, one is public and another one is private. Just look, you are having a key of your house, then in that case you are having only one key, and you need just one key to unlock your door. But if you go in a bank and if you are operating a locker, then in that case you are having two keys. One is with you and another one with the bank. So unless and until you are having both the keys available with you, you cannot unlock your locker. Same here, public key cryptography, when we say we are having two keys, public and private. For encoding and decoding, we use both the keys, and one is made public, as the name says. The world is, this key is known to all the world. But the thing is that the private key is only available with, is only kept with the owner. So public key cryptography, short term is PKI, and it is also known by the term asymmetric cryptography. It uses two pairs, public and private. And as you have seen your physical key, in this case we cannot use a physical, it need to be in the digital form. So this key is generally a very long binary number, generally 256 bits or 512 bits or more, 1024 bits and so on. So the public key is distributed worldwide and is truly public. The private key is to be strictly held private, and one should never lose it. In the case of the Bitcoin, you never lose the private key, and this private key is generally attached to your Bitcoin wallet, and you are being identified with this combination of the you could say key. The entire if you lose it, then what will happen? The entire content of your wallet would be instantly vulnerable to theft, and before you know it, all your money would be gone, with no mechanism in the system to trace out. As we have already seen that anonymity, it is working on the principle of anonymity. PKI basically used for two purposes: authentication and for maintaining the privacy. Privacy, that is the encryption and decryption, which we have earlier seen. How the authentication is being done in the with the PKI. Suppose we are having two parties, Bob and Lisa. Now Lisa want to confirm whether the message coming from the sender side is actually the Bob. So when the two parties exchange the messages, it is important to establish a trust between sender and the receiver, and this is how this trust factor is being maintained in the blockchain, because everyone is anonymous. So the maintaining a trust between the sender and the receiver party is very, very important in the case of the blockchain. So especially the receiver must trust the source of message. Going to our earlier scenario, which we have shown in the figure 1, Bob sending some money to Lisa for purchasing of some goods from her. Let us see how PKI build this trust between Bob and Lisa. So in this case, what we are having, Bob. Now Bob, when he's sending this message, what is the message that he is transferring this much amount from Bob to Lisa? He will sign this message with the private key. Now what is the meaning of signing here? It is basically, you could say it is encrypting the data, and this encryption is being you could say it is being said as this it has given the term signing here. So what he will do, he will convert the message into some encrypted form, and for conversion he is using the private key. So he is signing with his private key. Now on the, this is your internet. So if person is sitting and he happened to allow for MITM attack, then in that case the message would be known to him. But the thing is that since it has been signed by the private key, he cannot see the exact message. Now what will happen? The message from Bob, it will come to Lisa. Now Lisa will authenticate the Bob by using the public key. Now this public key is earlier being shared with the Lisa. So in the first place, if Bob wants to send some money to Lisa, he has to create a private public key of its own. Note that both keys are always paired together, and you cannot mix the private and that is you cannot use public key as a private one and the private one as the public key. Both need to be remain separate. And moreover, it is being created for the different, that is every time the transaction Bob is carrying out, he is creating a public private key pair. Now Bob says that he is sending $10 to Lisa. So he creates a message, plain text message containing Bob's public key, Lisa receiver public key, and the amount. The entire message is now signed using Bob's private key. When Lisa receives this message, she will use the signature verification algorithm. For example, it can be your DSA of PKI and Bob's public key to ensure that the message indeed come from the Bob himself. This establishes the authenticity of the message. How the privacy is being done, same concept would be followed, but the thing is that how we are using the private and public key and where. On the basis of this, we will see whether we are going for the authenticity part or whether we are going on the privacy part. So here, let's suppose Lisa received her payment and she wants to send the link to her ebook which Bob wants to buy. So Lisa would create a message and send it to Bob. But Lisa also wants that this link should be known to the Bob only and no one should be aware of this link. So what she will do? She will sign it with the Bob's public key. So now if the person is sitting here, then he will receive the message which is being signed by the public key. To get the exact link, he should have the private key of the Bob. But this private key is with the Bob himself. So when Bob received the Lisa's link of the resource, so what he will do? He will decrypt only by this message using his private key. So the Lisa creates a message such as, here is the link to my ebook which you had requested, sign it with Bob's public key that she has received in Bob's request message, and also encrypt the message using some secret key which is shared between the two when the HTTPS handshaking is being done. Now Lisa is sure that only Bob can decode the message using the private key. Also, if somebody is intercepting the message, then he would not be able to recover the exact contents because he is not having the private key. This is another important concept which is used in blockchain, and that this is your hashing function. So we are having a special hashing function or hashing algorithm, for example SHA-256, SHA-512, etc., which we can use to get a hash key. So basically, what is a hash function? You are having certain message, or you could say data, and you are passing this data to a hash function, a set of, you could say it is an algorithm, and this algorithm, it is generating a 32-byte hash value. Now this hash value, if someone get this hash value, then with the help of this hash value you cannot get the original message. Is of the size 256 bit, and it is in the hexadecimal format. So what is happening when you are creating the block? For example, this is my block 1 and this is my block 2. How you are maintaining the chain? You generate a hash value for this block and you store this hash value in block B2. This is how the chaining is being done in the case of blockchain. So Bob, while placing an order with Lisa, create a message. The message is hashed through a hash function. The beauty of this hash is, for all practical purpose, it is considered unique for the contents of the message. That is, if you change the message, then the hash value also got changed. Now, if the message is modified, the hash value will change. Not only that, given a hash value, it is impossible to construct the original message. Another important thing is mining. So I will explain the mining with the help of the Bitcoin. So when Bob creates a purchase request for Lisa, he does not send it to the Lisa alone. Rather, that request message is being broadcasted to the entire blockchain network. So if you look, we are having this blockchain network. Here we are having miners available with us, and few machines are my nodes. So what is the activity of the miner? Miner, what they will do? They will mine, or they will add the transaction in a block. So this is the mining process. After mining process, the miner is adding all the transaction in a single block. He is generating a hash function, passing this block into a hash function, and the hash value is being generated. So after a block of message is formed, the miner create a hash on the block. Now, as you know, if any third party modify the content, then the hash value got changed. So this is how the your blockchain, they are made tamper proof. Chaining, I had already told you that what we are doing, we are generating the hash value of a block and keeping this hash function, hash value, in the next block. So the very first block is known as Genesis block in a blockchain. So we have already seen SHA-256, that is hashing. So this is in the hexadecimal format, and it is generally, you could say, just as your fingerprint identify you. So similarly, a hash value identify a user. So each block has data, hash, and the hash of the previous block. Rest I will discuss later on in other video. These are the references which I had used while preparing the slides. Thank you and Jai.